practice also our mapping diagrams. So I'm going to give you this mapping diagram. Where we've got -2, -1, 0, 1, 2, and then we've got 4, 1, and 0. And I'm going to say -2 goes to 4, -1 goes to 1, 0 goes to 1, 1 goes to 1, and 2 goes to 4. I want you to first write this out as a set of ordered pairs. So writing it out as an ordered pair means that we would get -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then it says to graph the relation. And so we're just going to really quickly plot those points, those ordered pair points that we grabbed from a mapping diagram. So a lot of times we're like, oh, how do we represent that as a graph? How do we represent that in a way that makes sense, that we normally do? And this would be a nice, easy transition, is to create your points first. So we have things like 0, 0, 1, 1, -1, 1, and then 2, 4, -2, 4. Hopefully by now we're starting to see like, oh, this could be, doesn't have to be, a parabola. It could also be a, nope, I'm wrong. I was going to say that it was going to be an absolute value equation, but it's not. Okay, so here's our graph. So finding the relationship in the form x arrow. This is another way that we write algebraic expressions instead of y equals. It's like x arrow, and then it's like, okay, we're plugging in for x. Here is our computer function or relationship. So what we know is that it looks like a parabola, and double checking what we know about parabolas, that it's quadratic, right? So it means that something is squared. And then we can start looking at like, oh, well then -2 squared becomes 4. -1 squared becomes 1. 0 squared, 1 squared, 2 squared. So it's really just our x value squared. And that's how you would write this relation in the form x arrow, as opposed to y equals or anything like that. Just weird different ways that we like sometimes talk about it, but we don't tend to. It's not the way that we normally talk about it in classes leading up to 11th grade, but it is something that potentially will show up, that you might see a relation that looks like that. And so you just have to know that it's just a weird way of writing the equation. Okay. Last one. I would like for you to do this one. One, two, three, 4, 3, 5, 7, 9. We're going to have each of those just go right across. I'm going to write them as a set of ordered pairs. And then you can plot them, or kind of like the general idea of them. And then I want you to try and take a stab at it. What would be an equation that represents this relationship? It is a linear relationship. So how do we write equations of lines? You got this. You can do it. There are a few things that I could do this where I don't have to follow a formula if I don't want to. If you are somebody who likes a formula, do it. Use the formula to find the slope. Use then your point slope form in order to start the equation of the line, and then isolate for y so you can plug it into this form. But there's a few things that I know. I realized that my slope is that I go up 2 over 1, right? I go up 2 from 3 to 5. From 1 to 2, I go up by 1. So that means that my slope is going to be 2, 2x. And I can tell, I don't know if you saw me go here of like, oh, is that going to go down to 0? And it doesn't. If I continue that slope of down to back 1 or up to over 1, that means I go down to 1 and then down to 0. So my y-intercept is going to be positive 1. So there's ways to kind of think about it and visually figure it out. And if you understand the patterns and the behaviors of these linear functions, they should be pretty quick and they should go really fast. But we're still learning and we're getting there. We're working towards confidence and comfortability.